Following on from some of the earlier videos, we now need to look at case 3, where x is less than 0. So we need to show that the remainder heads towards 0 as n heads towards infinity, for the case of x being less than 0. So we need to show that this heads towards 0. So this is exactly the same as this. So now let's look at this and this. So forget about this for the time being. Forget about this. E to the power c. From the theorem, it says that c exists somewhere in between the center, which is 0, and x. C must exist somewhere in between here. Well, e to the power c is right here. E to the power c, e to the power c, you can see that e to the power c must be greater than e to the power of x. This is e to the power of x. This is e to the power of x. So you can see that e to the power c is bigger, must be bigger, e to the power c must be bigger than e to the power of x. But as it turns out, this thing here is useless. This thing here is useless. The reason why I'm doing this is just to give you an idea of what's going on. As it turns out, this thing's useless. What we need to be looking at is we need to compare e to the power c, which is this bit here. E to the power c is going to be less than e to the power 0. You see, this point here is e to the power 0. So e to the power 0 is 1. So e to the power c is right here. E to the power c would be less than e to the power 0, would be less than 1, would be less than 1. So you can make this statement, but as it turns out, this statement is not true because it gets more complicated now, because x is in the negative realm. Because x is in the negative realm, this block here could be a negative. For example, if you put a negative 2 into here, if this thing is if this thing here is even, then you're going to get a positive. If this thing here is odd, then you're going to get a negative. So this thing here, yes, even though e to the power c is always less than 1, it becomes more complicated because x is in the negative realm. X is in the negative realm. So this block here could be a negative. This block here could be a negative. So for example, let's say e here, e to the power c is going to be less than 1. Let's just imagine it to be 0.8, say. And let's just imagine this block here to be, well, it could be a negative. Let's imagine it to be negative 10. So this here is negative 10. But then you can see negative 10 here is not greater than this thing here. It's actually bigger. It's actually smaller than this thing here. So as it stands, this thing here doesn't make sense. What we're interested in is the absolute. We need to look at the absolute value of this thing here. We need to look at the absolute value of this thing here, because the area, the remainder is really the magnitude here. So by looking at the magnitude, if you look at the absolute here, you're really looking at the magnitude here. You're looking at this magnitude here. If you look at the absolute, you're actually looking at the magnitude, the gap in between these two. You're looking at the gap in between these two. You're looking at the gap in between these two. So we should be looking at the gap in between the two rather than looking at this. We should be looking at the absolute value of this whole thing. Okay, I hope you follow that. So we should be looking at the gap. We should be looking at the gap. Taylor polynomial can be above this thing here. Well, we're interested in the gap, in the gap. So by looking at the absolute, we are looking at the gap in between the two. By looking at the absolute, we are looking at the gap in between the two. Well, let's look at the gap in between the two. The gap being this thing here, being this distance here. Okay, so now let's look at the absolute of the two. So now take the limit as n heads towards infinity. Well, as n heads towards infinity, we've seen in the past that this thing here heads towards 0. So the remainder will head towards 0. So if you look at this, take the limit of this as n tends to infinity. Take the limit of this, n tends to infinity. This thing here is going to head towards 0. Therefore, this thing here must head towards 0. So the remainder is heading towards 0. So what it's saying here is that the gap in between the two here, let's imagine this to be -7, and then here, sorry, the absolute value would be, the gap would be 7, and then this thing here would be 6, this thing here will be 5, and then the gap here is 3. You can see that as it gets smaller and smaller, the remainder here will head towards 0. I hope you can follow that. I didn't explain it too well. Okay, so we need to be looking at the absolute value. Okay.